This is unit number 3, video 14, molecular geometries and types of bonds. Going through the various molecular geometries, tetrahedral, trigonoplanar, linear, and then the subgeometries off of those. 4 electron clouds, 3 electron clouds, and 2 electron clouds, going tetrahedral, trigonoplanar, linear. So what we're going to do now is introduce the concept of certain types of bonds. We're going to start out just by drawing the structure. One of the things we want to be aware of, if we have several atoms, you can have more than one central atom and more than one geometry, because each central atom has a geometry around it. So I'm going to do a chemical called acetaldehyde. Here, the Lewis structure, these hydrogens are directly after the atom they're attached to. So we're going to have C, H, 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 C. This hydrogen, since it's behind the carbon, is attached to the carbon, not the oxygen. H, O. I've got 4 and 4 is 8, plus 6 is 14, 15, 16, 17, 18 valence electrons. So my final structure is going to have 18 electrons. I've already drawn 2, 4, 6, 8, 10, 12. So that means that I have 6 available to complete the octet. This carbon has an octet. This carbon has 6, it wants 2 more. This oxygen has 2, it wants 6 more. 6 plus 2 is 8. I'm going to draw a bond. There's only one place I can draw that bond here, so no resonance. Draw it here, and I have this type of structure. Okay. So, geometry around this carbon. Well, this carbon has 4 electron clouds, therefore it's tetrahedral. So that's a tetrahedral geometry. Geometry around this carbon has 3 electron clouds, it's trigonoplanar. So I could draw that out and name the geometries, give a 3-dimensional look to it. Like that. Okay, so that's our 3-dimensional geometry. Now, we're going to identify some bonds. The most efficient place to put electrons in a bond is between the sets of protons. So if I have positive charge, and I'm going to put a cloud of negative charge, that cloud is going right along the bond between the 2 positive charges. We call that type of bond a sigma bond. Okay? And the first bond between any 2 atoms is always a sigma bond. Okay, it's the most efficient way to have the electrons set up, and that's what occurs naturally. Now, once there's a pair of electrons along the bond, that next set of electrons, even though it's right there, is not going along that bond. They're going to repel each other. So what happens is, if these are my protons, now that next set forms from the sideways overlap of 2 p orbitals. We get this type of overlap on side to side. You say, well, how does that occur? Well, I've already told you that double and triple bonds are shorter than single bonds. So the atoms are going to scrunch up. When they do, the p orbitals can overlap side to side. We call that a pi bond. Sometimes you hear these called banana bonds. Okay? Literally, the electron density is above and below the axis. Here's the axis. The electrons are sitting up here and sitting down here because there's already a sigma bond sitting here. Okay? So if I wanted to analyze this for sigma and pi bonds, okay, this would have 1, 2, 3, 4, 5, 6 sigma bonds and only 1 pi bond.